Hello, you're watching the first part of a tutorial about the plate reconstruction software GPlates. The voiceover that you are listening to now was recorded in 2025, but the rest of the video was recorded in 2017, and that means that some of the things that you will see in this video will look slightly different from how they will look on your own computer if you're following along and copying my steps. For example, in a minute I will show you where to find GPlates on the web to download it, and that page looks entirely different now. You're forwarded to a different web page, but the steps are all the same. And in GPlates itself, at least for the functionalities that I will show you in this video, nothing has changed. Alright, with that said, let's get started. Back to my former self from 2017. GPlates is free software that you can simply download from gplates.org. On the homepage you see this big green download button and you want the latest stable release. And then there's a whole bunch of files here that you can download. In case you're working on a Windows, you need this file, and for Mac users you need the Darwin file. I'm not going to show you the rest of the installation process because GPlates is already installed on the computer that I'm working on, but the process speaks for itself. So if you install GPlates on your computer, you now have the software, and you also have a folder called sample data. On a Mac, you can find that folder here. So in applications, there's this now GPlates folder, which contains the application itself and then also the extra folder sample data. On a Windows computer, on your C drive, program files, GPlates, and there it is. I would suggest that you make a folder that you call GPlates, where you're going to store all the files that you'll be working with. And I would copy this sample data folder to that folder as well, just to have everything in one place. 2025, me again here. One extra thing before we can start, we have some more files to download from Brightspace. So on Brightspace, go to Content and then to the folder Practica. In that folder you will find a subfolder GPlates files, and there are 3 files to download that are called tutorial.gpml, tutorial.rot, and tutorial_data, which is a Word file. Download them and save them in that same folder that you just made. Okay, back to the video. Let's open GPlates. I'm just going to close this to make my screen a little bit bigger. Basically, GPlates works with 3 different types of files. And we're going to start with opening all 3 of them so I can show you what they are. Go to File, Open Feature Collection. Then search for the sample data, rasters, and then open this file, the color etopo file. You see that this is a .gpml file, and it's a shape file, and in this case it's a map of the world. So if we open it, we get a world map. I'm dragging the globe just by using my mouse, clicking and dragging. Close this window for now. Such a file is called a raster file, and in fact it's simply an image. So for example, a JPEG that is converted to fit into a globe. You can use any JPEG that you want and import it as raster file into GPlates. So this is the first type of GPML file, and there is another, which is that tutorial.gpml file that you downloaded. So if you open that one, I'm also going to open this one. The tutorial.gpml file contains all these colored lines that you see here. So the orange and pink lines here in the South Atlantic, the coastline of South America and Africa, and gray Europe. And this is called a feature collection. It's literally a collection of features, and these features can be anything from coastlines, mountain ranges, magnetic anomalies, volcanoes, folds, literally anything. You can select a feature by clicking on the green Africa button here on the left, and then here I click, for example, on the coastline of Africa. And then here on the right you can see you get some information about this feature. So the type of the feature is a coastline. In this case it's Africa, and it has a plate ID, which is 701 in this case, and it's part of the feature collection tutorial.gpml. because we now clicked on the select icon, I can no longer drag the globe. But if you hold Control on your keyboard, you can always drag. For a Mac, that will be Command. You see that the right set of marine magnetic anomalies in the South Atlantic are the same color as Africa, and the left set is the same set as South America. And this means that they have the same plate ID. So if I select one of those lines, it's an isochron, so it's a different type, but it has the same plate ID, 701 in this case. And if they're the same color, they have the same plate ID, which means that they're they're part of the same place. You also open the tutorial.rot file, but that file does not contain anything visible, and I'll come back to that in a minute. To check which files are open, you can always go to Window, Show Layers, and you see that there are 3 files and they all have a different color. Yellow for the ROT file, green for the feature collection, and orange or reddish for the raster file. In this window, you can also change the visibility of your layers by clicking on the eye. So, like that. The keyboard shortcut for this layer windows is Control L or Command L for Mac users. The ROT file contains descriptions of movement of the different plates with different plate IDs. It's a simple text document that you can open in a text editor. I'm just going to open it, go back to my folder, open the ROT file simply in Notepad. There we are. And it contains Euler poles of rotation of one plate with respect to another in 6 columns. So the first column here, which is 101, is a plate ID, and the last one is a plate ID as well. The first is the plate that is moving, and the last one is a fixed plate. So it's always rotation of one plate with respect to another. Then the second column is H, and these 3 columns are the Euler pole in latitude, longitude, and rotation. So moving plate ID, H, latitude, longitude, angle of rotation, fixed plate ID. And then after the exclamation mark, you can just write remarks, anything that you want. So for example, the reference to a paper or the names of the plates. Such a table of finite rotation poles always starts with a line of zeros, as you can see here, because in the present, the finite rotation between 2 plates is always 0. And here you can see that the angle of the finite rotation increases when you go back in time. So the relative motion between, in this case, North America, 101 is North America, 701 is Africa, becomes bigger and bigger going further back in time. The second half of this file contains rotations of Eurasia with respect to North America. So 301 is Eurasia, and here we see 101 again, that's the last column. So we have Eurasia with respect to North America, and then North America with respect to Africa, which means that indirectly we also have the motion of Eurasia with respect to Africa. So we now only have 2 sets of rotation poles, but you can imagine that this file can become much bigger, and we call this a reconstruction tree. Africa is always at the base. So it's like the root or the trunk of the tree. Okay, now that we know how the rotation file works or what it looks like, let's go back to GPlates. And first, I'm going to minimize this. Let's tell GPlates that we want Africa to be the root of our reconstruction. So we go to Reconstruction, specify Anchored Plate ID, and I'm going to fill in 701 here, which is Africa. Just to make it a little bit more clear, I'm going to not show the world map right now. So this means that we want Africa to be fixed and the rest of the plates to move. The top panel here, it has a window for H and then some play and pause buttons, and also this slider. So if you use this slider, you see that North America and Eurasia are moving. South America is not moving because that was not in the reconstruction file. But the green and gray Eurasia and North America's shapes are moving over the globe. I can drag the globe a little bit. And Africa, as you can see, is fixed. I can also just go to a certain age and see what it looks like then. As you can see, Eurasia is drawn, but Iberia is missing. Spain and Portugal over here is missing. And what we're going to do is we're going to add Iberia to the GPML file. So I first want to make the world map visible again. I'm going to go to the present day. I'm going to zoom in to Iberia. Make sure that what I did before you start drawing, time is set to 0. And to draw, you click this icon. And then I prefer this one, so you can either draw a line or a set of dots, or this is a closed shape, a closed polygon, and that's what we want. And I'm just going to zoom in a little bit further, drag my globe, and start drawing here. Just by clicking. Here on your right, you can see the latitude and longitude of the points that you're actually drawing. Just gonna drag my globe further and further and draw Iberia. You can use any amount of detail that you want. As you can see, the edge of southern France is drawn in quite a lot of detail. You can follow that line if you want. You can also make it just a little bit less detailed. For now, this will do. Okay, so I'm back to where I started. When you're done and you're happy with the geometry that you drew, I'm pretty happy with this, I click Create Feature. This is a coastline, so I'm going to select coastline. Next. The plate ID that we're going to give Iberia is 304. And let's say that it starts existing, or it appears 300 million years ago until today, and the name is of course Iberia. Next. Next. Now you can choose where you want to save this feature, and you should choose this file. You can make a new GPML file, or you can save it into the world map, which is a bit weird. You should never pick the ROT file, because that's, the notepad file, the rotation file, is not a shape file. So we're going to go for the GPML file, create. Okay, and there we have in red Iberia. So you now added a feature to the GPML file, but it is not yet saved. And we can do that in File, Manage Feature Collections. You see that the tutorial.gpml file is red, the other two are white, which means that it has unsaved changes, and you can just click Save over here and then close it again. Okay, the next step now is to add rotation poles for Iberia in our rotation files, because we want to reconstruct Iberia back in time. These poles can be found in the literature, And I would like to show you where such rotations are based on. So a couple of years ago, a group of researchers from Utrecht, you might recognize some of these names, Paul Meijer, Reinhard Vissers, Douw van Hinsbergen, they studied the rotation of Iberia, and they published their results in, well, these 3 papers, Earth Science Reviews and EPSL, and we can now use those results in our GPlates reconstruction. This is a figure from one of these papers, and it shows the marine magnetic anomalies in the Bay of Biscay over here. This is a figure for 79 million years ago, and Iberia is not attached to southern France, and it is today, but there's a small gap. And that gap represents the crystal shortening that took place in the Pyrenees between 79 million years ago and the present. Before 79 million years ago, the rotation of Iberia can be reconstructed by using these marine magnetic anomalies. The youngest anomaly over here, the A34, those are 83 million years old. And the oldest one, M0, that is 121 million years old. So between 83 and 121 MA, by reconstructing the spreading in the Bay of Biscay, so by closing this bay, Iberia rotates and eventually ends up here. So Vissers and Meijer calculated the final rotation pulse, and you can find them in the tutorial data file that you downloaded from GPlates. So there's this Word file, and it contains total reconstruction pulse, and we have ages, latitudes, longitudes, and angles. So that's everything we need for the rotation file. So now we can simply add these. Let's open the rotation file and add at the bottom a new row. So Iberia is 304. For the present, I'm gonna start by putting in some zeros. The rotation is gonna be with respect to Eurasia, so 301. And then I'm gonna just copy this, copy and paste. And now this is of course only the age, lot, long, and angle. So we need to add 304 here. And then we add 301 as the last column. All right. I'm going to put an exclamation mark here and to specify that this is Iberia with respect to Eurasia. And the reference, this is Vissers and Meijer 2012. Okay, save and close. And then we now added or modified the rotation file. We did that outside of GPlates, so GPlates doesn't know that yet. So now you can either open the rotation file again, but there is an easier way. In the Manage Feature Collections that you can open with Control or Command M, there is a reload button over here. So the ROT file went to reload. And now it tells me that there is an error, which is interesting. Okay, let's open it again. I guess it doesn't like those empty lines. Save again, close, and close. Do the reload again. Yep, that's it. Okay. And now, if everything went okay, Iberia should be moving with respect to North America. There we go. You see this convergence or the shortening in the Pyrenees, and then the rotation of Iberia. That's it. Back to, okay. So as you can see, at 121 million years ago, Iberia is quite far away from Eurasia. I'm just gonna not show the map again. So this is the gap between Eurasia and Iberia. Then if you go further back in time, it switches back towards the present day position, because the only poles that we added were 221. So, see? Okay. So what if we want to reconstruct Iberia further back in time? We go back to this image. There are anomalies over here. They're older. And they're also part of the Iberian plate, at least the right side of these marine magnetic anomalies. But now the left side of these anomalies is part of the North American plate. So if we use these anomalies, they provide us with information about the rotation of Iberia with respect to North America and not with respect to Eurasia, as these ones from the Bay of Biscay. Again, you can find those poles in the data file over here. So now we have total reconstruction poles of Iberia versus North America. It starts at 126 and it goes to 203 million years ago. So we can make the reconstruction a lot further back in time. Now, what we have to do, we cannot simply copy this and add this to our rotation file, because we first have to make a step over. So we make a step over from Eurasia to North America. And a step over is an extra line, in this case at the age of 121. And with that step over, we can move from relative motion with respect to Eurasia to relative motion with respect to North America. So what we need to make this step over is the Euler pole of Iberia at 121. I'm going to go to 121 million years ago. But now we don't want the Euler pole with respect to Eurasia, but to North America. And to get that pole, we anchor North America, specify anchor plate ID. North America is 101. You see the globe moved a bit. I'm going to select Iberia. And then I'm going to click on this icon. And what is given here is the Euler pole of plate ID 304 with respect to 101 at time 121. And this is the extra line that we want to add to the rotation pole. So a rotation file. So now I'm going to go to my rotation file. And I'm going to add that extra line. 304, 1.1. Ooh, okay. I now see that this is 101, 121.2, so I'll have to do that here as well. Okay, slightly different order pole. So 0.2. So my Euler pole is 64.7236. Latitude minus 18.9886. Longitude with an angle of minus 58.1369. Okay, with respect to 101. Okay, so now we have two lines with the same age with a step over from Eurasia to North America. Save. And now we can simply add the information from this table. So I'm copying and then pasting, and again, add 304 as the first row, and then 101 right now. That's the last one. I'm gonna put an exclamation mark here and write step over to North America, and the reference now becomes Vissers and Meyer 2012, and Vissers et al. 2013. Okay, save, and let me just check those empty lines. Yep, delete, save again, and close. And again, I'm going to reload, Control M, reload my rotation file. And now, look, Iberia is moving further back in time. With making that step over, you see that now North America is anchored. So Africa is moving and North America is kept in place. Of course, if you want, you can anchor Africa again, or any other plate for that matter. By the way, if you open GPlates, the anchored plate ID is always set at 0. And if you don't change that, you'll see that nothing is moving because there is no plate 0 in your rotation file. So don't forget to choose an anchored plate ID every time that you start. Okay, I've almost come to the end of the first part of this tutorial. We've covered how to draw a feature, how to add published rotation poles to the rotation file, and how to make a step over. And I'd like to finish off with a little exercise. Most of you will have been in Cadaqués in Spain last year, and you know that the actual zone of the Pyrenees is very much deformed. Estimates of total shortening in the Pyrenees are in the order of 100 to 150 kilometers, but shortening is not necessarily the same as plate convergence. So my question is, based on your reconstruction, how many kilometers of plate convergence did there occur between Eurasia and Iberia at the location of Cadaqués, which is, for those who do not know, here at the tip? I'll show it with the map. This is Cadaqués. So at the location of Cadaqués since 121 million years ago. There's a tool over here in the select icon. There's this tool, which allows you to measure any distance between 2 points that you click. So 2 points, you can measure the distance. When you've measured the amount of plate convergence, maybe you can also figure out what the difference is between convergence and shortening. So why are they different? And that difference, what does it represent? Okay, good luck with figuring this out, and I'll show you the answer in part 2.